Hey, hi all. Welcome back to BLR Knowledge Center. And in this session, we'll talk about microservices more in detail with some case study so that you will have a good understanding on what is microservices and how it is working and how it is overcoming the tedious configurations and other, kind of challenges which got, uh, having it in the monolithic and modularized architectures of software development. Okay, let us quickly get into this session, and I'm just navigating to the my next slide here so that you will have good understanding now. I'm just navigating here. So when I look at here, I have a monolithic here, so which have an application, right? So when I have a monolithic application, as I mentioned in the earlier sessions, everything is being, everything is going to be built up on a single file or single stone or single object, right? If you look at here, so I have basically three services or three kind of objects which I wanted to implement, like catalog and product and payment. Okay, if you look at here, these three are kind of components which got implemented inside of my application. And as I said, this is a single kind of a file and the monolithic architecture, everything being implemented inside of a single file. Okay, so now when I want to get a catalog list of all products or with their related pricing list and kind of summary of how many products being purchased, and how many payments are being done with respect to each product and the kind of price. If I wanted to get this kind of summary or in detail information of my product list or catalog list, what I need to do is I need to navigate through all these areas inside of my single application, right? So with this, what was the problem? As I mentioned, that it's very tedious job for every developer because everyone is working on this single application. So if I make a change or if I add a code snippet to the existing kind of here in the application, I need one all other developers to verify that it must be validated, it must be verified before being released into production, right? So this is one of the challenge basically I have in the monolithic, that if you wanted to do a small updates to the existing code, I need to look at other areas which you are interlinked with this because it's purely tightly coupled architecture there. So to separate the concern of code, at least for the development, so it was transformed into a kind of modularized architecture like this way. So here what it is having is a catalog was being transformed into module 1, and orders being transformed into module 2, and payment got transformed into module 3. Okay, so now I was separated my code concern, the concern of code into different components, but still it is interdependent. Even though I just separated my code into different components, loosely coupled or decomposing of my code into different models here, but still it is high cohesive. That means it's tightly interdependent of all these components inside of my single file here. So only the thing and the difference between this monolithic and modular architecture was you're just now separated the concept of code into modules, but still you have interdependency with all these kind of modules with each other and having it in the relation. So if you made a change, if you make a change in the orders, so you definitely need to verify the catalog and the quick payment kind of models, because these three are internally having interdependency and huge kind of relation between these all these things. And I can say these are a layer architecture. I could say if you're doing a modification in the business layer or data access layer, you have to verify other layers like UI layer and service oriented architecture. If you look at that, there also you need to have a business layer and DAL layer where it has database operations. So if a change is happening in some place, you must make sure that all the areas being properly tested and unit tested and reviewed, and should be run through all these scenarios, right? This is what the basic problem we have in the modular architecture. So again, to avoid these problems, so as I mentioned, one of the problem was, I'm just okay. Let me put it here. I think I'll just stop my thing. Yeah, now it is fine. So some of the challenges we have in modular architecture was updates. So as I mentioned, so if I wanted to update something like in orders or payment or catalog, I need to check with all other team members who are associated with these different components to unit test properly and push the code into repository, and then smoke test the URL before they give a release to the production or UAT. And coming to the second drawback, right now I think I have it is architecture was team management. So as this is again kind of a single a stone, a single file, we have all models. So there is a problem with the team management, because so the catalog one and orders and payment, all those people are sharing of their work, and one team is going to implement all these models and components. So definitely there will be a problem to manage the team. Let us say some example that, so I'm working on catalog, and which I'm not aware of payments, but catalog team is only looking at the catalog service. So if I wanted to make a change in the payments, I need to check with the team of payment team and get the KT and the kind of surrounding areas to be tested once I make a change. So it's not kind of making a change. It's a kind of a problem with the managing of team also, because if any change is happening in the payment, I need to talk to the orders and catalog team, developers, that how it is happening in the same. So let me take a break here, pause, and my recording. This is what the another problem we have it. And coming to the next one is deployment. So again, if I make a change in the payments, so I need to deploy other components as well into the production or live, even though I am attached other models, because it is tightly coupled. Sorry, it's high cohesive. So high cohesive where the testing needs to be done on orders and catalogs. Suppose if I make a change in the payments, I should look at the orders also to make sure that the query parameters, other input values are coming properly to the payments or not. And similarly in the catalog. So deployment wise, it's very no kind of a time taking process for me, because entire system, entire application needs to be deployed. And again, the kind of team has to be dedicatedly sit with that to test the all the scenarios again to move forward. And again, coming to the next one, maintainability. And when it comes to maintainability, so as I mentioned, this modular and monolithic architecture kind of development, all this development code files, and the code changes being pushed into only single repository. That's where the major problem. So when there is a kind of a change happening it here, and the different components and different teams are working on it. So definitely when you are pushing into a kind of a GitLab or Git, you make sure that there is no conflicts happening between the two team changes. That way, I think you make sure things are going in smooth, and then you again do a smoke test kind of stuff. And again, if something is adding a feature or adding a kind of a line of code, you make sure that everyone has to be tested, all the models. So I should warn, or I should let the other team members to verify their models along with my change. That's where the problem for the individual developer, where actually is working on the payments, he has to inform the other teams which catalog and others, saying that, so there is a, hey, there is a change is happening in the payments. You make sure to validate and verify that the change with all your features in the respective models. That's where the problem comes to the developer to maintain the teams or maintain the code change, whether it was in the push or the Git repository or unit testing of the code change or functionality testing or any kind of smoke test between different teams. And these four tedious challenges we have it in the model and monolithic architecture. To overcome these all things, so this modularized architecture being transformed into microservices. So where you have microservices differently, like a catalog was in one microservice, and orders was in microservice 2, and payment was in microservice 3. So when it comes to microservices to overcome these updates, as I mentioned, all these things being in a single file or single repository. When it comes to microservices, I may have a different repositories because catalog was purely independently survivable code file, so I can push in a different branch, but certainly not in the same branch because it is independent, right? So when I have multiple repositories, I'm not worrying of other development code or conflicts, because definitely I should not have any conflicts because I'm dedicatingly working in a single repository. I must so admit my changes immediately. So no need of other pull request changes or code review challenges being done by other teams, because certainly this is a different repository. So with the multi-repository concept, with these microservices, the updates kind of stuff was very easy in the microservice. Coming to the team management again, in the microservices, so this was something a two-pizza team. This was basically introduced by Amazon, where so the people who are eating two pizza, so the team length also should not be more than that size. So instead of managing 10 to 15 members in the kind of a monolithic or modularized architecture kind of development. So I certainly have 4 to 5 people with stack or no all kind of skill set persons, because I'm going to split into this and different sprints and then having assigning it to different teams. Team size was minimal for me to manage this. So when I have a minimal team size, so I certainly very happy to manage it because it's very easy for manage and reviewing their performance, right? And coming to the deployment, so as I mentioned, microservice was independently deployable and no worrying on other teams changes, other team changes. So I can independently deploy my orders or catalog or payment in a different server, right? So and coming to the maintainability, so again it comes to smaller changes. When I made a small change in my payment, it would be in different repository and it would be in different server and it would be in different machine altogether. I'm not worrying on kind of maintainability for me, because if everything being in the same server as like in the monolithic or modular architecture, the horizontal application scaling was very no kind of low level. So application scaling, uh, if you wanted to increase it, we must deploy in different machines using microservices so that it will increase horizontal what scaling. That means adding of your systems with the same stuff of deployment, and then vertical scrolling of vertical scaling by just increasing of your power of your server like a RAM and memory. That's that way I think you will be scaling your application, and then deployment and release cycle is going to be very faster in this microservice architecture. And coming to the another feature was a multi-programming language. When it comes to monolithic or modular, so you certainly need to select one language, and all the teams should work on the same language, either C Sharp or ASP.NET or Java or kind of Angular or React. But when it comes to microservices, as I mentioned, it was an independent kind of component. So where you can choose different programming languages. Let us say microservice one was being developed in C Sharp and .NET Core or something, and Service 2 was in Java Spring Boot. Service 3 was in the Python Flask design or UI concept. So, and like that, so I can choose different languages in for different microservices. Certainly, I'm not bothering about so what language I'm going to use it, because it was independently deploying on the independent server, and it doesn't have any dependency with the kind of other components or other services. Certainly, I have a different programming language. That way I think programming developers also very kind of enthusiastic to convert or transform this modularized architecture into microservices because of they are learning different technologies as per the current market. And coming to the next one was multi-DB engine. So again, so when the modular and monolithic, so we definitely go with one or two databases, right? So not more than two databases because it's tightly coupled or high cohesive kind of architecture. When it comes to microservices, I may develop this one service in SQL Server, second service in Oracle, third service in Mongo. So like that, I can choose different programming languages and different programming DB engines. That's how it is scaling my application and covering all the problems which got um, you know uh, um, um, impacting in modular and monolithic architecture to manage the large scale applications of software development. So I hope you understand the concept of microservices with this case study like catalog and for orders and payment, and why it was transforming into microservices from monolithic and modular architecture because of these many cool features and overcoming of these kind of updates, team management, deployment, and maintainability challenges. Thanks for listening this video, and please subscribe this channel for more videos, and thank you.